Are you ready to embark on a journey of success? To discover your true potential in the untold stories of careers in life sciences? Welcome to PATHFINDER by the Purdue Institute of Inflammation, Immunology and Infectious Disease. With your host, Tommy Soares, discover the untold stories of industry scientists and unveil the secrets to excelling in your career. Thank you for joining us once again, and remember to hit the like button and subscribe to our channel. Welcome, everybody. My name is Tommy Soares. I'm the Director of Scientific Strategy and Relations for the Purdue Institute of Inflammation, Immunology and Infectious Disease. And today on Pathfinder, I have the pleasure of welcoming Josh Johnson, who's an analytical chemist at Corteva Agriscience, located in Indianapolis, Indiana, where he acts as a mass spectrometry subject matter expert and manufacturing analytical leader. Josh earned his PhD in chemistry in 2020 in Dr. Scott McCluskey's lab at Purdue University, and continues to utilize his skills and the skills that he learned at Purdue to solve some of Corteva's most difficult analytical challenges. Welcome to the program, Josh. Thank you so much for taking my invitation and being here with us to talk to us.
Yeah, thanks, Tommy. I appreciate the invite.
One of the fascinating things for me that drew me to want to talk to you for Pathfinder is to see how your transition has really been from the university now to an industry corporate lab. And what was that process like? And, it's fascinating to talk to people as they are not necessarily in the midst, but in closer proximity to when the transition has happened from leaping out of a university lab into industry. So, as always, I'll let you take us back as far as you want to take us. And the microphone is yours, and tell us how you got into science and all of that good stuff.
Yeah, sure. So I guess I can go back to undergrad, really. So I went to a really small undergraduate school for my bachelor's in science. And I actually got my degree in environmental science, but I didn't start out as a scientist. My first year and a half at Gardner-Webb, I was actually a political science major.
Okay.
And it wasn't until I went to one of my professors and asked, what kind of job can I get with this degree besides a curator or professor? And they couldn't give me a good answer. And that day I went over to the science department and declared as a environmental science major. And really from that point on, I got really good mentorship. It's a very small department. The classes were, my biggest class had 20 people in it. And my senior level classes I had 2 people in some of my classes. So I got really that one-on-one attention that I thought really helped me grow as a scientist and, learn about the fundamental research process. I did some independent research projects. I did an internship my junior year at Florida State, the high magnetic lab at Florida State University with another former Gardner-Webb grad. So that was a really cool connection I made. David Podgorski, he's actually a assistant professor at Tulane now. So he really gave me the ability to understand high level research and get my feet wet in that. So that's where I found out about mass spectrometry, which is what I'm doing now. And as they say, the rest was history. I applied for graduate school at Purdue, #1 in analytical chemistry, had some great mass spectrometry professors. I did my research in Scott McCluskey's lab doing instrumentation, which coming from a really small school with no mass spectrometers actually at the school and then going and building mass spectrometers was a really big transition. However, I learned a lot firsthand from that experience and was able to, leverage that into a career move into industry. And my goal was always to get into industry. I never really wanted to be a professor. I did enjoy teaching and TAing But yeah, my goal was always to go back to, how can I solve problems with the skills that I developed in undergrad and graduate school, and at an industrial level that is very useful, and the types of problems are very diverse, which is really fun for me.
And so, do you think you're really an engineer at heart? Because, like, to build mass spectrometers, you gotta have some good engineering behind you, at least liking to build stuff. I mean, I remember loving to build Legos when I was a kid, and I thought, oh, genetic engineering is kind of like building DNA Legos type of thing. But what about you? What do you think is hiding under you that it's just like, yeah, I can build mass specs?
Yeah, so the funny thing about that is, I just enjoyed the challenge of it more so than the engineering bit. I mean, I can talk shop with, engineers. I work with a lot of them here, but it's really more about, developing the skills to solve the problem that's put in front of me, more so than, I really like this part of the project or this part. I liked being able to find cool and interesting things that I could go and develop those skills for, not necessarily even like chemistry or engineering or, whatever. It's just, hey, where's the challenge and how can I develop enough skill sets to meet that challenge? So even though, going back to getting into instrumentation, that was a huge challenge. I didn't have programming background, I didn't have an engineering background. I learned all of those on the fly. I had a really great mentor, Eric Dykonsky. He's actually a research scientist in Graham Cooks's lab now, who helped me develop those skills such that when he left and I had a new graduate student under me, I could kind of, take the ball and keep running down the field with the project that we've been working on. So I would say I'm more problem solving oriented than like, an engineer at heart.
Well, but I think that's very much engineer in
True.
spirit, let's say, because
Right.
engineers love solving problems. You give them problems, and they'll figure out what tools we need and what we can use and so on.
Right.
That is fascinating. I love it. I think your time at Gardner Webb must have been really like key to making you drive, making you build this work ethic that uh you know that whatever problem you face, that you were going to tackle it and be able to find solutions to it. What Tell us a little bit about the mentorship that you got. You talked, well, and maybe importantly to talk about that seminal moment where you're like, there are no job options. Was it political science that you were first driven to? And you're like, there, I don't like the job options because of what you're telling me. I gotta go find something else. And then environmental sciences, what a leap. But then also like getting exposed to this one-on-one mentorship. Tell us a little bit about that. What was that like?
Yeah. So the natural sciences department encompassed the three science majors, not including mathematics, that Gardner Webb offered, which were biology, chemistry, and environmental science. So there were in total 4 professors who taught all the classes for those, of which some of them, we had an organic chemist that was teaching inorganic. So there were, it was really bootstrap kind of teaching where, they may have been experts in a certain area, but they were like, they learned the other area to teach students. So it kind of always had that kind of like gritty feel to it, where it's like, hey, we're not an R1 university. We're doing like we're trying to keep things afloat. We're trying to give you the best experience you can. And part of that is this mentorship that we're going to offer. And I had a really great, uh, all of my professors were fantastic, and they were all very personable. And, they're the type of professors when we would have like an undergrad lab, instead of having a TA, you had the professor there with you that could, answer your questions, and they're walking around like helping people out. So you really got to learn from them as opposed to, other students. So there's a different level of like dedication to that learning than
Mhm.
I feel you might experience at a larger institution. But I had in particular, I had a professor, Dr. Stefka Edens, who is my undergrad mentor. She really stressed, the research part of it. And like, no matter what you're doing, everything is research, whether you're doing experimentation, whether you're doing book learning, right? Or, whatever, you're always doing research. So she really stressed to me, hey, we can only offer you so much at Gardner Webb as far as like learning kind of what I was interested in. So that part of that was me applying to Florida State to get, a research education or a research experience for undergrad internship that summer. And that is what really opened up my eyes and said, hey, it's a very different area, and, I'm going to have to develop a very different skill set, but, I can do it. And I can, as long as I have the focus, I can get out there and learn these things, which is kind of, I leveraged that experience and said, hey, I'm deficient in these areas. I need to go and get better at that if I want to be a researcher in, mass spec and analytical chemistry. So I just kind of took that same thing into my senior year and then straight to, Purdue and Scott's lab.
That's awesome. And did you get to build mass specs in Florida too?
No. So in Florida, I was actually doing, it was really cool. It was petroleomics. So
Oh,
I was actually looking at how different types of petroleum
yeah.
photo-oxidized. Like, so oil slicks in the ocean, like if one type of oil has, a lot of sulfur versus not a lot of sulfur, like how does that affect how it degrades? So I
Yes.
was doing ultra high resolution mass spectrometry, and then doing a lot of data analysis to understand, what the core compositions of the degradation products were. So it was a really cool blend of environmental science and then mass spec. And then I just kind of fell in love with the mass spec part. So
Right, and it's reminiscent of Hilka Kentema's work also at Purdue with
yeah.
the looking at the oil omics.
Oh
What do you
yeah.
call it? Petroleomics?
Yep. Petroleomics. Yep.
I love it. I think that's great. I had never heard of petroleomics, but that's and so you really got to apply environmental stewardship to this new field that you were tackling.
Mhm.
Did you actually get to do experiments outside and look at, some stuff in the ocean or with ocean water and stuff like that?
Yeah, so unfortunately, I only had so much time. So a lot of the samples were kind of like shipped, and it was much more like in lab. But I will say, at my time at Gardner Webb, I actually did a lot of, very simple analytical chemistry, but, because we had very simple tools, but that kind of gave us the freedom to go out and like try it on interesting stuff. So we did like analytical chemistry on like different types of beers that our professors would like bring in. They'd be like, oh yeah, we're gonna analyze the aromatics in this IPA versus this, stout,
Nice.
or we're going to go sample the water out of the local spring and see how safe it is. So they were very creative, which I really appreciate. And I kind of, anytime I have an intern here, I try to kind of bring that same mindset where it's like, okay,
Yes,
here are the tools that we have. How can we get creative and do fun experiments?
totally.
So,
And so were they mainly like colorimetric or type of,
yep.
very fairly simple analytical diagnostics, right?
Yeah.
For
So we had like
oh,
we had like
AA.
flame absorption, and then like
Yes.
IR.
Yeah.
We had an HPLC and a GC, which were nice instruments, and I think we had a really like low resolution NMR that we could use, but it was very very
Nice.
simple. But the fact that
Nice.
there weren't a lot of students meant that you had access to a lot of them, if
Yeah.
you wanted.
So, okay, so you go from this analytical chemistry uh adventure, I will call it, to then now like you got to build mass specs. And what are the skills that you needed to get to in order to start thinking about, well, how do I start building a mass spec? Where do I start from?
Yeah, so I would say the first maybe it's not a skill, but the first prerequisite if you're jumping into anything new is having someone to kind of teach you the ropes, or at least somebody to kind of give you a foothold. And, I think Scott is a great, Scott McCluckey's a great mentor. I love the way that he runs his lab as far as, the older students are really sought to be like the mentors for younger students. So every project you join, you'll have an older student that's like assigned to mentor you. So that was really the fundamental part of it. And what I really wanted to know is, how does a mass spectrometer work? And what better way to learn that than to get hands deep into like a mass spectrometer, right? So that was really, I was really driven by understanding, I really wanted to understand how it worked. I wasn't driven by, oh, I really have this great idea for like a new, mass spectrometer. It was really just like, I want to understand how these work so that I can find cool ways to work with them. So yeah, I learned how to breadboard, I learned how to solder, I learned MATLAB, I learned, you know, ion simulations, all these things that I had never thought to even, you know, look at, or, I had no idea that they were even involved in the field. But that really built my base as a mass spectrometrist, which I think, going into industry, you get a lot of people who come out that were doing like proteomics, a lot of applications based stuff,
Yes.
which is awesome because it's a different skill set. But, I think not as many people come in with a really core fundamental understanding of what's going on inside the black box, which I think is what I wanted to demystify for myself so that I could, when I brought an application, I knew exactly what tools in my, toolbox I could solve it with.
Well, and so I think from your PhD, it sounds like mission accomplished. Not only did you build the black box, but you miniaturized the black box too, right? Tell us a little bit about this in a sense, right? The mass analyzer that you made.
Yeah. So miniaturize may be a strong word, but yeah, we played around with a lot of different aspects of the instrument. And I mean, I think that was a really cool part about, the project that I was working on, the electrostatic linear ion trap, is that, we're the only group in really the world that was using it the way that, that we were looking at ion ensembles as opposed to like single ions that were bouncing back and forth in between these plates. So we had a lot of freedom to operate, as they would say in business. We were not, nobody was going to scoop us. Nobody was going to, so we could really just play around and take our time with experimentation and what we wanted to do. And part of that was like, hey, if we change the distance between, these plates, can we increase the frequency, which will, change these figures of merits and so on and so forth. Some of the interesting stuff that I did later on, some of the first author publications I put out were just simply saying, hey, if we turn these, plates on and off at a certain frequency or at certain times, like, what does that do? How does that affect things? And can we see new cool things? So a lot of it was driven by like pure curiosity, which I thought was maybe different than other labs where you're doing more application stuff where it's like, hey, this is the endpoint we're trying to get to. We're trying to measure this endpoint. Like, how do we get there? It was more so like, hey, what cool, fun things? How can we explore this space? How can we've opened up this dark room. How can we take our flashlight and start, walking around and finding things out?
I love that. I'm gonna have to pick up a copy of your thesis, man, because it sounds fascinating. It sounds like, oh my gosh, you clusters and ion clusters and like what's going on and like what's happening? Are they grouping? Are they not separating? What's so interesting. I also want to say that there's a lot of to be said about the team around you, and as you said, it's important for people, I think, to acknowledge, and this is really parking your ego aside and acknowledge that when you face a problem, when you face a challenge, when you face something new, it's not typically how you're going to do it, but you said it most poignantly in that who's going to help me to tackle this. And I think we forget about that because we tend to panic in the moment of like, oh, I have this situation I got to get out of. I got to do it all myself. And it's very daunting, but it typically requires us just mustering the courage to go ask people for help. Tell us now. So, okay, PhD, my gosh, MATLAB and like boards and alligator clips. I'm sure you you were in
Yes.
the Amy lab for a long time there, working with Mike and company. I can only imagine what that must have been like. But now you go to Corteva. Um, I want to hear first, how did you find out about this position at Corteva? And how did you apply, or how did they recruit you? What happened there? What was that transition?
Yeah, sure. Yeah, before we talk about that, I mean, I think you make a really good point about, really putting your ego aside and never being afraid to ask for help. And I think that comes back to, you know, when I was looking for jobs and when I was even looking at different labs to join, that was a big part of it. You don't want to join. There's certain cultures that you want to be a part of and certain cultures that you don't. So, that's one of the reasons I joined Scott's lab. All the labs at Purdue are fantastic, but I just really enjoyed the way that he ran his group. Um, Everybody, was very happy to help. It was very collaborative. It was very much, hey, we have group meetings on Saturdays that could have gone for like 3 or 4 hours, but it wasn't because, it was made to go that long. It was because students were presenting research and, other students had ideas and wanted to help. And nobody had a big ego. You could say something, if you didn't know something about a project, you could say something and it'd be kind of ridiculous, but hey, that might be the start of a new research project because nobody had thought about it like that. So I think that's one of the great things about a group like that. And you look for the same thing when you're applying for jobs. So I started my job application process really early. So I kind of knew approximately when I was going to graduate, May of uh, March-ish of 2020, which is obviously in hindsight, a very lucky time to have graduated because it was right as the pandemic was starting. But I actually got my job offer in October of the year before. So I said, hey, I'm graduating this, in March. So that's when the soonest I can be available, and they didn't have problems with that. And I actually had a couple of different job offers because I got started early and I started making those connections through, LinkedIn and the different graduates from Purdue. There's a huge network out there that sometimes people overlook, even from their own, group. So a lot of Scott students have gone to work at Merck, Pfizer. I mean, they're all over the place in universities. So I feel like people don't use LinkedIn quite enough. I'm a big proponent of, hey, reach out to people. You'll be surprised as to who is willing to help you in the job search. So I actually got my offer from Corteva while I was at another interview. So I was just like really putting myself out there, trying to get a head start. But the thing that I looked for at Corteva was, one, what kind of people were in the group? Two, what type of problems did they try to solve? And then three, where did I fit in? So I think those are the three big pieces that I, kind of went to in my job search. And what I found here was, one, a group that was relatively small, a group that didn't have anybody that had a heavy instrumentation background and needed somebody for that. And then a group that was not afraid of the fact that I didn't have any like experience with applications. I didn't have proteomics or like even small molecule pharmaceutical development. I didn't have those skills that might have been,
Right.
disqualified me, quite frankly, from other jobs. They're like, hey, we need somebody with this skill set. Don't worry, we'll teach you the rest. So that was one of the big things for me. And, I've really enjoyed it. And I think people here would say that I've learned quite a bit of organic chemistry and quite a bit about the process to register a molecule.
For sure. I'm sure you have. And I'm sure also that you bring a very different perspective than an applications person. And I hope the people that are watching or listening to this podcast get that nuance, that there are machine builders, and then the people that use the machine to do stuff like proteomics, metabolomics, lipidomics, whatever other types of analytical ways that you would use a mass spectrometer. But here in this case, they probably purchase mass spectrometers from, regular companies, and then there you are to maybe help troubleshoot. Is that right?
Mhm.
Troubleshoot, make sure that the instruments are all humming and they're all behaving where they're supposed to be.
But even like, how do you decide which instrument to purchase?
Mm,
That's another question that, an applications person may not have the best answer for.
right.
Whereas somebody who has more experience looking at the figures of merit for different instruments and may even have vendor relations, you know, might be able to add some perspective to that. But even, not being afraid to go really deep into something and then come out of that. I feel like that's kind of where I'm at right now in my career is, you get really deep in an area, but then when you're in industry, there are a lot of specialists, but it pays to be a generalist sometimes. So
Mm,
not being afraid to learn other skills. And I know mass spectrometrists don't always want to admit this, but realizing that mass spectrometry might not always be the right tool for the job. Um, whether that be because it has to be solved in a certain time frame and we
yes.
don't have the skills in a certain area. But sometimes people come to you with problems and it's like, hey, you know, I could do this, sure, and I could go out and buy this and develop that, or I could use some more available, some simpler things and figure it out that way. So I
Mhm.
think that's as I've been in industry, I've become more of a generalist. And
Mm,
you know, some of the more recent papers I've published have been on, collaborating with Hilke Kintema's group doing high molecular reactions, doing 2DLC for hydrogen deuterium exchange in a 2DLC, and then we're working on a current manuscript doing gas phase, ion spectra or gas phase spectroscopy
yeah.
as a tool for structural elucidation. So just being flexible and just kind of finding the right tools for the job and
Yeah.
not being too proud to go to other areas.
But I agree with you. I think that definitely brings this innovative perspective to the people that you're working with, because you probably are working with some application specialists and you're like, well, have you considered complementing that data with using this data that we can pull from this, and we can really tackle it and
Yeah.
from these different perspectives and really understand what's happening. Um, did you do you think, though, that there is, I mean, there's so much progress in the tools, especially with data manipulation and on the software side. Uh, do you think you're going to continue to be mainly hardware, or do you see yourself like opening up more also to the software as well?
Yeah, for sure. I mean, software is, you can't look at the data without a, good software package. So I think we're always very sensitive to what software is available. Um, for what we do, so small molecule structure elucidation is really what our group looks at. The tools are really mature. A lot of the innovation is happening, at least from the vendor perspective around, proteomics and looking at, MABs and, antibodies and stuff like that, all this
Yeah.
stuff surrounding COVID and that type of stuff. But, from our point of view, it's actually kind of, yeah, software is great, but we are really focused on, how do we not do the same thing more than once? So my big push right now for our group is like, hey, we have a lot of mass spec groups that may be siloed. How do we like build a central like library for us to never do the
Mm,
same structural elucidation or look, have to redo the same uh, mass spec interpretation twice to make data more available for everybody? Because it's the big data problem, right? All these Corteva is a huge global company.
yeah.
There are a lot of mass spectrometers, a lot of people are taking data, but that data, you know exists in silos. And how do you take all of that data, put it in a single place, and make it kind of have data equity, right, between
Sh-
everybody, data
sh-
equality? So it's less about really the tools to analyze the data itself and more about the tools to make sure everybody has access to the same data sets when we're looking at, the same, however many compounds we have in our pipeline, however many operate existing molecules that we're currently selling.
That's awesome. I agree with you. And I think, it's a real challenge for all of us to really tackle. It seems that if there's something in the public databases that can also be mined, if there's some, like duplication of effort, my gosh, we should be like finding those quickly so that we can divert. So it seems also to me like you are expanding your knowledge both beyond science, because I saw that you just got an MBA as well. Congratulations, sir.
Thank you.
That's impressive. Tell us a little bit about that. Was that your doing, or did you have a mentor in the company that said, you would be good at maybe going to get an MBA? What was that?
I mean, that was really driven by, the same reason I wanted to learn more about mass spectrometers because I didn't know, a lot about them. So I went in and tried to build them. I didn't know a lot about how businesses were run or why I was doing some things. Why were we pursuing these projects versus these? You'd get these quarterly, here's our EBITDA for the year, and we are either at or below or above. So you get these things and like you wouldn't understand them, and you just be like, okay, I see green and no red, so that means that it's a good year.
Yes.
So just wanting to understand not only the broader scope of like what we're doing, but also what's important for my leadership, people who aren't in lab, what's important to them. They may not necessarily care about how many, spectra I collect in a day or how many projects I'm on, but they may really, really care about, this operational effectiveness thing that they're doing, or, this thing over here, or like, how do we do things faster, or how do we do things more efficiently? Or like, this project is really, really important right now. I'm okay if you drop the ball on these other things as long as you're paying attention to this. And this is why we're doing it, because it's at this stage and it could bring us like this amount of money. So really understanding, trying to step back and look at me from my leader's eyes, I think is really kind of what drove me to do that. Obviously, getting your MBA involves other stuff that might not necessarily like finance and accounting, but because I took those, I now know what EBITDA means, and I now know like all of these things that are in our report to our investors and stuff like that. So I kind of understand that, as well as some of the larger macroeconomic pressures that Corteva faces from like different areas of the world, and trying to get why we're doing what we're doing. Obviously we're making, our goal is to, feed those who like support consumers and, and farmers, obviously. But, on top of that, there's a business aspect to it too, and understanding, all the different regions that we support, and, how we make money and how our leaders provide value to the company. I think all of that is why I wanted to do it. And, I wasn't supported through my work. I paid for it out of my own pocket just because I was interested in it. And yeah, it's definitely paid dividends. I've talked to a number of young students who are trying to get into industry, and they look at my, LinkedIn profile, and they're like, "Oh, I see you have an MBA. Should I just go and get one?" And I'm like, no. Go get a job, try to be good at your job, understand kind of the base, build your base. And then, once you get to the point where you really want to learn about, what's going on in like the broader kind of economy of the business that you're in, then that's when you take that next step and get your MBA and start making that strides in that area.
Yeah. And, who's to say that you really need to get the MBA if you continually learn, right?
Sure.
On the side, you can read books about business and teach yourself about some of the concepts, the lingo, so that you understand what they're talking about. I'm sure there are also a lot of resources
Hmm.
available for free online, because I've tapped into some of those
Yep.
resources too, and they've been great.
I'm just impatient.
No, and I think there's also a lot to be said, as we've noted in the conversation, about mentors. You know, you can probably read a book on how to build mass spectrometers, but it's not Scott McCluskey there
Hmm.
telling you, hey, you should think about this, you need to consider that, you need to do that. And like there's a lot to be said about the experience that they bring to the table of having done it so many times.
Yeah.
And
Yeah.
and having that interaction with a mentor like that can be a wonderful way to grow, uh, because of you trying to emulate people, or trying to understand better, or trying even to, like, not show off, but like, bring the best of yourself to not
Hmm.
disappoint them as they're trying to mentor you. I think that's wonderful, and
Hmm.
commendable to you for taking it upon yourself to do it. What was the reaction around the office and the company? Were people like, "Are you crazy?" Or were they all supportive, or good for you? What was that
Yeah.
like?
So the only person I really told was my direct supervisor. I didn't really tell anybody else. It was just kind of like, hey, I'm going to go out and get this information. The
Yes.
degree wasn't for like a promotion, it wasn't for anything other than like me wanting to just understand the business, understand how Corteva operates, understand analytical sciences as kind of like a business unit as part of this bigger, you know, corp like bigger company. And then I graduated and I added it to like my LinkedIn profile and to like my name at the bottom of my emails. And people were like, "Ah, when did this happen?" I'm like, I've actually been working on this for like a year and a half.
Yeah.
But I mean, it's just, you got to like learn that type of stuff. Cause I mean, when you're at a company, money is finite, and if you want to justify like purchasing something, you have to know how to put together like a proposal. It's like grant writing almost.
Yeah,
It's like, how do you put
absolutely.
together a business case to get this
Yeah,
product? What are you solving?
right.
What are your deliverables? What is your plans? How much is it going to cost? Have you thought about that? It's all very similar to putting together like a plan to like start up a
Yes.
company.
Yeah, yeah,
So, and yep.
absolutely. No, and it's a similar thought process and a similar way to tackle it, right? Um, how did you balance it out? Was this like evenings and weekends, or what was the schedule like, and how did you balance it with your daytime job?
Yeah, so the nice thing about the program that I went through, it's called Quantic. It's online only, so I mean you can literally do almost the entire thing from your phone.
Mm,
Um, it was a lot less expensive than some of the school options, which was attractive to me because I was funding it myself. Um, but yeah, it was a lot of weekends. Over Christmas, I had like a 30-page report on, taking a failing business and providing input as to how we could make it better, and providing like financials over the past 3 years and what areas you could tackle. And I
mm.
did that over Christmas, and I would sit at the table in the morning, do a little writing, talk to like my parents about like, hey, you guys know this company, like, what do you think about this, and this? So it was just weekends and trying to make it as fun as possible, and trying to take it and apply it to, not everything was applicable to what I'm doing. So some of it was harder than others,
Yeah.
but there was a great section on, team building and like organizational, like how do organizations work, team dynamics. Um, and then there were sections that were less useful, like accounting, but you just kind of you try to balance it with like your family life and work, and just do it on the weekends primarily. It was probably like between 10 and 15 hours a week of work, I would say.
Yeah. Yeah. Well, it takes commitment though, and
Yeah.
you're gonna have to want it, right? You're
Yeah.
gonna have to want that diploma or certificate at the end to say, I
Yeah.
did it, so that you can write those three letters after your name. But Josh, tell us a little bit now about what's your day to day at the company. What I know you spoke a little bit about structure elucidation. Tell us a little bit about that, and what how do you structure your daily schedule so that you're productive?
Yeah, absolutely. So analytical sciences at Corteva, we have kind of two analytical science groups. We have crop protection, discovery and development analytical sciences, and then regulatory analytical sciences, and they focus on kind of different things. Um, uh, Crop protection, discovery and development, our group focuses primarily on pipeline and operate existing molecules, looking at the molecules themselves, the processes to make those molecules, and then degradants and stuff like that. Whereas regulatory looks more at metabolites and stuff like that. So I would say, so our group is divided kind of into three different areas. So analytical sciences, we have regional labs, which support kind of molecules that are already kind of out in the world, formulations that our farmers are currently using. Then we have a GLP group who is certifying molecules that are kind of already existing or standards that are coming in. So they do more of the routine stuff. And then we have what's called analytical research, the analytical research and development team, which is what I'm part of. And those are the subject matter experts that tackle the hard stuff, whether that be developing new methods for new formulation concepts for molecules that are being developed, helping the process engineers and process scientists that are trying to scale up a molecule from I can make a little bit in a flask to now I have to make a metric ton of this, and this same chemistry is not going to work. So how do we change it without changing the tox profile? So within ARDT, it's separated into 4 disciplines. So it's separation sciences, inorganic, spectroscopy, and then structural elucidation. And I'm part of the structural elucidation team. So there are 3 of us. I am, it's a diverse group. So like I talked about, teams need to have a certain build to kind of operate most effectively. You don't want 3 people with instrumentation backgrounds like in the same group. That doesn't help a lot. So we actually have 1 scientist who was trained in total synthesis of natural products. And then we have myself, who is instrumentation. And then last year we hired a scientist whose background is in ion spectroscopy. So kind of a bridge between the spectroscopy group and the structural elucidation group, because we're primarily mass spec focused. Other techniques. So what the projects and molecules that are in our pipeline, and we are an embedded resource into those groups, and we help them with identifying new impurities that pop up while they're doing route scoping, as well as when we do generate a new large batch of material, we need to understand everything down to 0.05 area percent in the chromatogram, so like to a very, very low level, and we have to have structures assigned to those. So we help them with that's our job, is to identify those and work with the process chemist to mitigate those. But on top of all of that, we also work with the manufacturing plants all around the world to help them with any degradation or impurity problems they might have that could shut down a plant and cost us like millions of dollars. So it's very there are a lot of different areas that we touch, which I find very exciting, because that means that I get to see a lot of different things, whether it's different molecules, different, looking at formulations with different things in them, or even like, hey, here's this, the white powder problem. Here's this unknown. I need to know what it is. Use any analytical techniques possible to figure that out for me. So I find it very, very interesting. And I would say my day-to-day is probably like 50% meetings to talk about, developing the scope around these problems and like what the actual needs are. And then 50% in lab, either taking data or doing data analysis.
Awesome. So interesting. And I gotta tell you, it's been a real pleasure learning from you and getting to know you and getting to know a little bit about your world. Are there any questions that I didn't ask that you wish I asked?
No, I mean, my big thing is just what I would tell to people that are either looking for a job or in undergrad or graduate school is just never be afraid to network early and reach out to people. Um, that's one thing that I'm just so glad that I did really early on in my career is just reaching out to people, learning like what it's like to be in industry, what it's like to even be a research scientist when I was really early on. Um, Never be afraid to, reach out and just ask people like what is their day to day like. It doesn't always need to be asking for a job. It can just be asking for information. And I mean, I think that's something that I found a lot of value in and I think is underutilized.
And if people want to get in touch with you to ask you questions, can they do so by LinkedIn? Is that the right way to go?
Yep. Yeah. So
Awesome.
LinkedIn is definitely the go-to. I'm very active on LinkedIn and even once we get, once you make that introduction, I'd be more than happy to take like a Zoom call or take a call on the phone and talk to you about, my life. Doesn't have to be about Corteva, it can be about anything.
Well, it's been a pleasure learning today about your life. And thank you so much, Josh Johnson, the research investigator at Corteva Agriscience in Indianapolis, Indiana. Thank you so much for being our Pathfinder today. And I hope you have a great day. See you
Thanks,
soon.
Tommy.
Bye-bye.
See ya.
Thank you for joining us once again. And remember to hit the like button and subscribe to our channel.